In section 2.2, we're going to start to see some more complicated algebraic equations that we're going to be solving. But the references we made in the last section are still going to hold true. We're still following these rules. In this section, we're going to get all the way up, I think to here, all the way up to variables on both sides and combining like terms and using the distributive property. And our goals remain the same. We still want to get the variable alone on one side, and we need to make sure that we're keeping things balanced as we do it, that whatever we do on one side, we do the same thing on the other side. So let's look at some examples. To solve this equation, I go through my list of questions. We haven't seen fractions and decimals yet. We don't have any grouping symbols. So the next question to ask ourselves is, are there any like terms that we can combine? And I see a 9b and a negative 3b, then a negative 8 and a positive 5. So just like I did with expressions, I want to combine those like terms first. So 9b take away 3b is going to leave me with 6b's, and a minus 8 plus a 5 leaves me with a negative 3, equaling 21. Now that we've done that, this expression looks a lot like the ones we solved in the previous section. So I'm going to get rid of the negative 3 by adding 3 to both sides. Now I have 6b equals 24. And I can get rid of the 6 on both sides by dividing by 6. That leaves me with a final answer of b equals 4. We still need to check our solutions and make sure that they're correct. So I'm going to check it by putting the 4 all the way back up here in the original equation. You never want to check your answer with some changed portion of your equation, because what if the place that you made your mistake was going from here to here? Then you've only proved that the wrong equation you wrote, this is the correct solution to that wrong equation, not to the original equation. So I'm going to come up here and write 9 times 4 minus 8 minus 3 times 4 plus 5, and I'm hoping that all of that's going to turn out to equal 21. So following order of operations, 9 times 4 is 36. Negative 3 times 4 gives me a negative 12. Then 36 take away 8 is 28. 28 take away 12 is 16. And 16 plus 5 is 21. So I did end up with the same number on both sides, so that answer checks out. In this next problem, we go back to our list. We still haven't seen any fractions or decimals, so we don't have to clear those. But for the first time, we're seeing grouping symbols, the distributive property. So we're going to have that be our first step, to distribute the 7 over the 2 and the minus r, and distribute this 2 over the 3r plus 8. That'll give us 14 minus 7r minus 6r minus 16 equals 24. Be really careful with that second distribution. I see a lot of students taking that negative 2 when they distribute it over the 8 and not remembering that the negative needs to come with the 2 when it multiplies by 8. So this does need to say minus 16, not plus 16. Okay. So we don't have any grouping symbols left, so we're going to ask ourselves about like terms. Sure enough, this has a positive 14 and a negative 16, and then a minus 7r and minus 6 more r's. So when I combine the like terms here, minus 7r minus 6r is going to give me a total of negative 13 r's. My plus 14 minus 16 gives me a minus 2, or a negative 2. And now my equations look like the ones we've solved before. We still haven't seen variables on both sides, so we can come down to getting rid of the addition or subtraction. I'm going to get rid of the subtract 2 by adding. That leaves me a negative 13r equals 26. And then I'm going to divide both sides to get my final version of r. In order to get the full 13 and its negative to go away, I'm not dividing by 13, I'm dividing by a negative 13 on both sides. And 26 divided by negative 13 will give me negative 2. Looking for a spot where I can check this answer, because it's a big long one. Let's see if we can carve a space out right there. Okay. 7 times 2, oops, minus 2, minus a negative 2. It's going to be tricky to get in there. So 7 times 2 minus a negative 2, and then negative 2 times 3 times negative 2 plus 8 is all supposed to equal 24. Okay. So this 2 minus a negative 2, inside that parentheses I can turn that into a positive 4. In here I have 3 times negative 2, that's a negative 6, and negative 6 when I add it to 8 gives me a positive 2. That's supposed to equal 24. Then my next step is the multiplication. 7 times 4 is 28, 2 times 2 is 4. And when I subtract those two, sure enough, I get 24, equaling 24.